Good morning, everybody. We are going to continue our study in the solar system. If you are following along in your Delta Reader, today we will be on pages 6 and 7. Pages 6 and 7. And we are going to be talking about gravity and the planet, the star, the sun. So we're going to be talking about those two things specifically today. Remember, yesterday and the day before, we covered very general information about our solar system. And we talked about the path that a planet takes and how that's called an orbit. We talked about how planets spin or rotate on their axes, and that each one of these rotations is one day. And each time that a planet orbits or revolves around the sun, that is called a year. The years, the length of the years and the length of the days vary from planet to planet based on the distance from the sun. All right, got that? Okay, let's continue on. Today we're going to be starting with gravity. And again, we are on page 6 in your Delta Reader if you are following along with us. Gravity is the force that pulls all objects towards one another. So gravity, I know that you probably think that gravity is holding us down on Earth, but what it's really doing is it is pulling us towards Earth. So gravity is the force that pulls objects towards one another. Gravity between the sun and the planets is what keeps the planets in their orbit and what keeps us on the planet. Gravity is stronger between objects that have more mass. Mass is the amount of a material in an object. The sun has a huge mass. Gravity is also stronger between objects that are close together. So, for example, the gravity on Saturn, which is huge, as you can see right here. Saturn has a diameter of 74,600 miles. Okay. And Earth, right down here, you can see is very small. And Earth has a diameter of only 7,900 miles, so less than 8,000 miles. And Saturn has a diameter of 10 times that amount. So the gravity on Saturn is going to be greater because the mass is larger. However, gravity is also stronger between objects that are close together. So, again, Earth is much closer to the sun than Saturn is. Saturn is, oh my, 887 million miles from the sun, and Earth is 93 million miles from, is only 93 million miles from the sun. So Saturn is again almost 3 times as far from the sun as Earth is. So that is also going to affect gravity. Gravity acts everywhere. For example, gravity holds objects onto Earth's surface. If you drop a pencil, it will fall to the floor. Gravity acts between Earth and the pencil. The pencil is pulled toward the Earth. The gravity is the force between the objects. So between me and the Earth, the force that's holding me on this planet, the force between my body and the Earth is gravity. So the gravity is pulling me towards the Earth. The pencil is pulled towards the Earth. Weight is a measurement of the force of gravity on an object. The pull of gravity at the surface of each planet is different. That's because each planet has a different mass and a different diameter. So the same object would have a different weight on different planets. So if you weighed 60 pounds, and most of you probably weigh between 60 and 100 pounds, if you weighed 60 pounds on Earth, you would weigh about 23 pounds on Mercury. Mercury is this tiny little planet up here, very close to the sun, but very, very small. Mercury, tiny, tiny planet. On Venus, you would weigh 54 pounds. Here's Venus, almost the same size as Earth, very close to the same size as Earth, but closer to the sun. So it's almost the same amount. So if you weighed 60 pounds on Earth, you would weigh 54 pounds, excuse me, on Venus. On the moon, if you look here, the moon is a tiny, tiny little planet. A moon, it's not even a planet. It's a satellite that revolves around the Earth. It orbits the Earth. On that place in the moon, you would only weigh 10 pounds. And on Mars, you would weigh 23 pounds. Mars is a little bit smaller than Earth, but it's also farther from the sun. And if you look here, Mars is farther away from Earth than Venus is, which is why they have much closer, the weight on those two planets is much closer, Venus and Earth. Your weight would be different on other objects in space. You would weigh less on an object with a weaker pull of gravity. Okay? All right, let's move on to the sun. Well, first tell me, what is gravity? Anybody remember? We just talked about it. Yes, gravity is the force that pulls objects toward one another. And what is it that keeps all of the planets in their orbits around the sun? What does that? Well, gravity. Gravity is the force that keeps all of the planets in orbit around the sun. When is gravity stronger? When objects have more mass. The more mass that an object has, the greater the pull of gravity. What is mass? Do you remember what mass is? What's the definition of mass? It's the amount of material in an object. Exactly. It's the amount of material, not necessarily how much it weighs, but it is the amount of material. If we were to drop a pencil, what would happen to it? It would fall. Yes. And the reason that it would fall is because gravity is pulling the pencil towards the earth. What is weight? Different than mass. Remember, mass is the amount of material in an object. Weight is a measurement of the force of gravity on that object. That's the difference. Why would an object have more mass? Why would an object have a different weight on different planets? Yes, because each planet has a different mass, and the weight of the object depends on the mass of both of them. So the mass of Earth is smaller than the mass of, say, Saturn or Jupiter. And because of that, the pull of gravity is greater the more mass that there is. It's greater, and it's smaller the less mass. Okay, let's move on. Let's talk about the sun. I've got a picture here for you. There it is. That is the sun. I'm not sure why my camera just did something weird. I hope it didn't do something weird for you guys. The sun is the center of our solar system. The sun is the largest object in the solar system. The sun is closest star to Earth, and it looks much larger to us than the other stars do. But this is only because the sun is so much closer to us than they are. The sun is made mostly of gases, hydrogen and helium. It gives off a huge amount of energy. Energy from the sun moves through space. The sun is the main source of energy for Earth. We learned that in our last unit when we talked about food chains and food webs. The sun is the main source of energy for Earth. Most living things depend on light and heat from the sun. Plants need sunlight to make their own food. And what was this process called? Exactly, photosynthesis. Good for you. I'm glad you remembered. Energy in that food passes to animals that eat the plants. And what are those plants called? Producers. And the things that eat or consume the plants? Consumers. You guys got this. The sun's energy also helps the earth to stay at a temperature that can support life. Okie dokie. So, what is the center of our solar system? Who remembers? Should be easy. We just talked about it. The sun. Very good. The sun is the center of our solar system. What is the closest object in our solar system? No, that's not true. What is the largest object in our solar system? What is it? The sun again, because that's what we're talking about. And the closest star to Earth? You got this. It's the sun. What is the sun made up of? Can anybody remember that? Two gases. Both start with an H. I knew you would remember. Hydrogen and helium. Those are the two. And what is it that the sun emits or gives off? Heat, yes, but energy is what we're looking for. The sun gives off energy. And what is the main source of energy on Earth? Again, it's the sun. What do most living things depend on from the sun? Two things that the sun gives living things that they need. Light is one of them. Heat is the other one. Light and heat. And how do we benefit from the sun? We personally. Well, let's think about our food chains. Plants need the sunlight to make their own food. This energy in that food passes to the animals. And the sun's energy helps Earth stay at temperatures that can support life. So when we eat the plants or the animals, that energy is passed from the sun to us. But also, the sun keeps the earth at a relatively even temperature. And I know some of you are going to say, well, then why is it 30 degrees today and in the summer it's 90 degrees? That's still a relatively even temperature. Those are temperatures that allow humans to survive. If the temperature of the earth were consistently below zero, as humans, we could not survive because there would be no plant life. Plants cannot survive when it's that cold. So if there's no plant life, then there's no animal life. And we are animals, so there's no human life. Okay, now in your Bright Thinker, you will have a copy of this. Weight on other objects in space. And we are also going to fill it in together as a class. If you do not want to print this out, you can write it into your interactive notebook. The important thing that you need is this chart right here at the top. So you will need to open that worksheet over and over or just keep it open to refer to that when you answer the questions. All right. And then what you're going to do is you're going to cut it out and glue it in your interactive notebook. I'm just going to write it in my interactive notebook so I can show it to you. I am not going to include the chart. I am looking for my pen. There it is. Thought I lost it. Okay, I'm going to turn my computer a little so I can actually write. As always, when we're taking notes, we start it with our heading. The heading is your name, today's date, which is 1/6/21. I know we made it, right? And the lesson is, let's call it Weight in Space. Weight in space. Okay. Question number 1. Now you're going to have to be looking at the chart as we do this. What is the title? I'm going to write down the question as well. What is the title of this chart? Actually, sorry. You can tell I'm out of practice, that long break. What is the title of this chart? Say it. Listen. What is the title of this chart? Say it. Listen. What is the title of this chart? Say it as you're writing it down. What is the title of this chart? Okay, well, let's look at it. What is the title of this chart? That's it. Weight on other objects in space. Weight on other objects in space. Okay, question number 2. And remember, you can get all of these answers from that chart. So you do need to have the chart open and be looking at it. Oops. If you weigh 60 pounds on Earth, what would you weigh on Mars? Listen. If you weigh 60 pounds on Earth, what would you weigh on Mars? Say it. Listen. If you weigh 60 pounds on Earth, what would you weigh on Mars? Say it as you're writing it down. If you weigh 60 pounds, and I'm going to abbreviate it with LBS, on Earth, and we are talking about a proper noun, so it does need to be uppercase, E, Earth. What would you weigh on Mars? What would you weigh on Mars? If you weighed 60 pounds on Earth, what would you weigh on Mars? Look at the chart and tell me. 23 pounds. You got it. You read that chart right. 23 pounds. Okay. Question number 3. If you weigh 90 pounds on Venus, what would your weight be on Earth? Say it. If you weigh 90 pounds on Venus, what would your weight be on Earth? Listen. If you weigh 90 pounds on Venus, what would your weight be on Earth? Say it as you're writing it down. If you weigh 90 pounds, and again, I'm going to abbreviate that, on Venus, and again, uppercase V because we're talking about a proper noun here. What would you, or what would your weight be? I'm sorry, I almost said that wrong. What would your weight be on Earth? And again, uppercase E. Question mark. What would it be? Look at the chart. Find Venus. Find 90 pounds. How much would we weigh on Earth? Exactly, 100 pounds. Okay, question number 4. Well, we're going through these pretty fast. Okay, if you weigh 38 pounds on Mars, what would your weight be on Mercury? Say it. If you weigh 38 pounds on Mars, what would your weight be on Mercury? Say it. Listen. If you weigh 38 pounds on Mars, what would your weight be on Mercury? Say it and write it down. If you weigh 38 pounds on where? Mars. Yes, again, uppercase. What would your weight be on Mercury? Again, uppercase. And that's spelled mer with the of her, cur with the of hurt, and ie, Mercury. Okay, let's look at the chart. Find Mars, find 38 pounds, Now follow it across until you find Mercury. What would your weight be on Mercury? The same, wouldn't it? It would still be 38 pounds. Isn't that interesting? And that has to do with the size of the planets, Mars and Mercury. Oh, you can't see it. Sorry. Let me spin it. That has to do with the size of the planets. Mars is here, Mercury is here. They're close to the same size, and the distance from the sun. Okay. Next question, number 5. Okay. If you weigh 10 pounds on Earth's moon, what would you weigh on Venus? Say it. If you weigh 10 pounds on Earth's moon, what would you weigh on Venus? If you weigh 10 pounds on Earth's moon, what would you weigh on Venus? Say it as you're writing it down. If you weigh 10 pounds on Earth, moon, what would you weigh on Venus? All right, let's look at the chart. Find Earth's moon. Did you find it? Find 10 pounds. Now go over and find Venus in that same row. 54. That's right. You would weigh 54 pounds. 54 pounds. Number 6. 2 more. If you weigh 23 pounds on Mercury, what would you weigh on Earth's moon? Say it. If you weigh 23 pounds on Mercury, what would you weigh on Earth's moon? Say it. If you weigh 23 pounds on Mercury, what would you weigh on Earth's moon? Say it as you're writing it down. If you weigh 23 pounds on Mercury, what would you weigh on Earth's moon? And again, these are both uppercase because we're talking about a specific one. Okay, let's find Mercury. Go down the column until you find 23 pounds. Now go across the row until you find Earth's moon. How much would you weigh? 10 pounds. 10 pounds is right. 10 pounds. And finally, question number 7. If you weigh 100 pounds on Earth, what would you weigh on Mercury? Say it. Listen. If you weigh 100 pounds on Earth, what would you weigh on Mercury? Listen. If you weigh 100 pounds on Earth, what would you weigh on Mercury? Say it as you're writing it down. If you weigh 100 pounds on Earth, what would you weigh on Mercury? Would you weigh on Mercury? Okay, find Earth. That's that very first column. Find 100 pounds. Now go across the row, across, until you find Mercury. What would you weigh on Mercury? If you said 38 pounds, you are right, 38 pounds. Okay, this is what your chart should look like filled in. If you need to pause the video so that you can make sure that your answers match mine, go ahead and do that. Otherwise, you're done. And I'll be back tomorrow on January 7th, which is Thursday, for some more exciting information about our solar system. You guys have a great day. Bye.